All right, we will be discussing relaying NFC attacks with Android devices. Well, this is an approved talk. Well, this is a very long title, but at the end of the day, we are happy to have reached an agreement between the two of us, between holistic relay attacks on NFC cyber payments with Android mobile cloud phones. And then we also have NA, FE, SE. So, you know Ricardo, he's got a PhD by the University of Zaragoza. He loves malware, he loves NFC and binary instrumentation. He likes all that. And that's me, Pepe Vila. Oh, the student is the one wearing the tie, okay, on the top photograph. So, very quickly, this is the agenda. Okay, let us break down the title. First of all, I tell you what NFC is, what happens with EMVs, credit card payment. Then we tell you what relay attacks are, then implementation on FSC in Android, then what we can do with it or not, and then last the demo so that you can see what you can do with an Android device. Okay, let's go for it. Near field communication is a set of technologies that enable radio-based communication between two devices in proximity. It is based on several protocols and specifications that those that appear on the screen, ISO, IEC. Well, we will refer to them from now on as ISO, okay? So it falls within the range of 13.56 megahertz, and then it allows us to transfer at rates of 106 and 424 kbytes per second. Actually, in this case, there are always two instances, the PC or the reader that will generate a magnetic field, and then the card that may act as a passive or active object. These passive ones are very cheap. They are just fed by induction, and then communication happens between the two of them. In the active case, the card needs feeding, and then, well, this time the communication is established at a higher distance. I said, well, 10 centimeters more or less, let us say above 10 centimeters, and this is one of the characteristics. It requires proximity communication. That is a security factor that is needed. So this is what I'm telling you. We have the PCD that feeds through the field this reader, and at the end of the day, this is like Wi-Fi communication. We will be modeling the information at the end, and then at the end of the day, we are just transferring and passing on ones and zeros. So why ISO IEC 14443? Well, this is the most widely used in Europe for credit cards. This is an international standard for this type of cards, and it is divided in 4 parts. The first 2 parts define the physical parameters, powering and modulation, and parts 3 and 4 tell us about the protocols. Well, part 3, as I say, defines initialization and anti-collision. We will talk about that now, and the fourth one is about the transmission protocol. Some cards follow the 4 parts of the protocol. They are known as type 4 ISO-DEP ones, but some of them only follows only some of them, or and well, MyFair Classic follows 1 and 2. I'm sure you know it all. And then the initial part, part of 3 about initialization, and then it has its own protocol. Then we have another specification, ISO IEC 7816. It also defines APD use, which is the transmission unit that is used for that. Without going into detail, initialization and anti-collision protocol of type 1. Okay, part 3A, we will have a reader, and the reader will point to the middle, and that is done through the requa command. Whenever a card is activated, is in the proximity of the reader, it will be activated, it will receive the command, and it will respond to that through a SECA. So if the reader receives several ATQs at the same time, it means that there are several cards, and therefore it will run an anti-collision algorithm. That algorithm will iterate up until only one of the cards responds, and then it will send out a response command. Well, the selection of the card is something arbitrary, okay? It selects any of the cards, and then by responding to that through the SAC command, and then in this command it is coded whether the card will support the part 4 of the protocol or whether it will support a proprietary protocol. If we are talking about a type 2 type 4 card, then, well, the transmission protocol will be similar. First of all, the reader, through RATs, requires a request ATS. Actually, it is asking the card, please tell me your parameters because I want to establish communication with you. The card gives out the parameters. If the reader doesn't like the parameters, well, they may renegotiate some of the parameters. But it is important to remember from here that at the end of this part, communication, logic communication is established between the reader and the card. Hard duplex means that only one of the two writes. One is writing, the other one is listening. And this is what the transmission unit does. This is the shape of it. We are talking about part 4. It has a header, it has a CRC, and then in the header we can define the number of, or the type of message. So we'll use the application layer, information, and then commands for response or for request. So we will encapsulate information in here. So the ISO 7816 was mentioned before. This is a standard for intelligent smart cards. And basically here we define the APDUs. This is the transmission unit, so the communication unit between the reader and the writer. And APDU is defined in this standard. And well, there are a couple of commands, okay? Command and response. And again, it will look like that. APDU command, first of all, it tells us the type of command that it is, whether it is a pay one, proprietary one, and the instruction means read, write, get data. I'll show you a list later on. Parameter 1, parameter 2. Some instructions require extra parameters, or if not, they are set to 0. And then the body. Then the length of the payload is defined, and as well as the length of the response that is expected. And then, well, that is dependent on what we have defined before, maximum 65 bytes, and then 2 status bytes. Then for it to get, well, for OK and for error, you need authentication. So there is a wide range of commands: read, write, get data. But the most important one is select. Well, it is not the most important one, but I'll explain what I mean by that. Well, smart cards, at the end of the day, are like a small operating system that is run on the card. It has a file system, and here you may have several applications. So when you want to communicate with a smart card, actually we are communicating with a specific application of that smart card. So each application will have an ID, and this ID is divided between the provider identifier and the extension. And the idea is that every time that we communicate, we select an ID, a specific ID, and from there we send a command to that application. Then in some cards, the implicit selection, some cards support the implicit selection. It is not that I do a specific select command, but when the application is run, starts, then by default there is an application that will respond. EMV, it's another standard. It's another application. Well, it's Eurocard, MasterCard, and Visa. So it defines communication between smart cards, ATMs, and point of sales. And it authenticates credit card, debit card transaction. In terms, it will use APDU commands to engage in, well, to do the communication, supports chip and pin protocol. You know it all. Well, there are many protocols defined. This is a very complex standard. We are not going to go into so much detail, but well, this I just like you to remember that it uses APDU commands. Okay, that's what we need. So these are the commands to implement EMV when we are talking about contactless payments. Okay, so Express Pay, Visa, and Mastercard. So, if you remember, when you pay with a contactless or with a magnetic card, then you swipe a track and then that contains information, okay? That is static, okay? And then the card is authenticated. So the advantage of contactless transactions is that APV is generated for each transaction. So even if it is intercepted, you will not get anywhere. So using that very same, the structure of a magnetic card allows not to make so many changes in the architecture that is behind it. And now I give the floor to Ricardo. Okay, this is for you to know a bit more about relay attacks or retransmission attack. They were first of all introduced by Conway in 1976. And if you, well, he specified that an attacker, a person who didn't know how to play chess, could beat a master of chess. How? Well, very easily, by challenging the, well, the man who doesn't know how to play chess is the one wearing the hat. He will challenge Alice, that is to say, White's game, and then another master is Bob. He's playing black pieces. Okay, he just establishes a chess game through mail. Okay, so sending out, I don't know, well, he sends out commands from one game to another. So Alice and Bob believe that they are playing against the man with the wearing the hat, but actually they are playing against them. These type of attacks are often used in scenarios where there are challenge and response protocols in place. The idea of this type of attacks is trying to exploit one of the principles that NFC is based on, that is to say, security based in proximity. So there are, well, I have some diagrams. So basically, this is, we are sending one of the elements to another, and then this other will communicate with the card. So communication with the card responds to that entity, and then it relays a response to the other entity that is communicating with a PCT. So this PCT would be a TPV, a terminal in the point of sale, and the PIN would be, the PIC would be a credit card in this case. So let me tell you about the framework of this work, okay? So in 2005, Gerald Hunker already introduced the hardware design specifically designed to make this type of attacks. If you want further information, you can, well, read the article. Later on in 2012, the first attacks were known to NFC transaction, in this case through Nokia mobile terminals that had this type of technology. Then the first time that these attacks were carried out with Android were being made with a specific version or a manipulated version of Android. Okay. Actually, this work, or the contribution of this work, is that we can prove that today you can do a relay attack by using off-the-shelf devices. For instance, an Android without any changes in the OS. You don't even need root permissions to do these attacks. And then we will also tell you what happens with the NFC architecture in Android.
Pero vamos,
Well, implementation in NFC Android started with Gingerbread in Android 2.3. That was 2012. So it supported the read and write mode. So we could use a mobile phone for that, for reading and writing. Then peer-to-peer communication, but although it was a bit limited, now Android Beam is much better. It allows you to do much more than that. And then card emulation. So mobile device was being used as a passive tag, and that was only supported by secure elements. This is basically a chip, a chip which is isolated from the system. It allows us to store information and to run applications on a secure environment because we cannot handle it from the OS. Technically, it is secure. And the way to keep it like that is like to access that device, you need to go through the intermediate authorities. In this case, intermediaries between the telecom operators, telecom mobile operators, and the manufacturers have the keys to install applications, and then the service providers. However, in this case, this environment was so closed that the only ones that had access to that were Google wallets, wallets and some bank entities. So we used the hardware emulation for Google Wallet payments. So we did that up until a couple of years ago. And what happens in such a closed environment? Well, it could not be used by everyone. And then developers start to say, okay, offer me something which is more accessible, because we all want to use our mobile card as if it were a credit card, or for instance, to make payments at the supermarket, for instance, to earn points. And the first solution came from BlackBerry in its 7 OS. They refer to it as soft secure element, which is also known in Android as host card emulation. And basically what you could do with that is to have the OS application to process the APDU commands and to respond to them instead of having an applet, a secure applet. Then in 2011, as Ricardo said before, Gear released a set of patches to support that and to allow host card emulation. The problem was that it was only valid for Android Cyanogen mod, and also only for NXP PN544 chipset. At that time, well, the only ones that used it were the Samsung and the Galaxy S and Nexus 7 tablets, but only the first generation of the Nexus 7 tablet, because then they changed this chip. And then in October 2013, Android officially supported HCE with the Android 4.4 version. And now I'll tell you about the details, what happened with the implementation in Android for the read and write mode, because this is the one that we want to use. Well, because we want to use our mobile phone, we wanted to talk to the card, and then the host card emulation mode needs a mobile to act as a card, or like to act as a proxy in an attack scenario. Implementation in Android. Android offers an API-oriented event-driven. So NXP and NCI. The first one supports a number of family of chips, and it is the only implementation that allows mobile phone to read these cards. I'm sure that some of you have a Nexus 4 and IFAR Classic cards are not read. So basically, as Pepe said before, the part 4 of the ISO protocol, in the case of NXP, it is proprietary. It's the proprietor. So, for instance, means that if another manufacturer wants to communicate with that type of card, has to pay to use that protocol. So, for instance, a company such as Broadcom says, no, I'm not interested in your cards. So that's basically what has moved or driven Google and other companies to switch from NXP to other type of chipset, which is more compliant with the standard, that is to say, more open. So implementation of NFC is that. Later on, this was standardized by the NFC Forum, which is an entity in charge of establishing a specification and standards related to NFC. NCI is an interface, and we focused on that, well, for the reasons that Ricardo told you, but also because chip manufacturers only need to implement the minimum base. So it means that a manufacturer has the possibility to have a chip that is supported by more mobile devices, and so that the mobile device supports several chips as long as they comply with that specification. Google with Nexus 4 switched to NCI, and ever since then it seems to be, well, the alternative, the good one, the one that is being used. Now Android does not support host card emulation for that chip. In the beginning, it worked with Cyanogen mode, but now if you have an ordinary Android, you cannot use it. So you will not be able to upload with money the cards that you have to buy coffee in your company. In NFC controller, well, NFC is controller interface. That will be the chip, that is to say, the element that understands the wireless environments. It will do the modulation. It will communicate with the Android OS through this interface. They will exchange messages, notifications whenever they change the status, or just data messages. So it allows you to do an abstraction, to create an abstraction to establish communication between the controller and the OS. Then in the case of writing and reading mode, Android applications cannot go into that mode right away. First of all, you need to register the application for the type of cards that you want to read, and then it is the NFC service that selects the card and decides to launch the application or not. So what do we mean by detecting a card? Well, basically it is NFC controller supporting a range of protocols and cards. Basically, this service will do a intermediate line, so which is equivalent of request to any protocol. It will dedicate 80,000 seconds to this protocol in this way. So another 80,000 seconds. It iterates, and then when the protocol responds, it means that there is a card with that protocol. It generates information about the type of card, then it sends a message through the NFC interface. It sends a message to the OS, and then the NFC service will generate an indent, which is a message between processes in Android, and then it will send it out to our application. And that's where we start to work. Here we start to work with the abstraction of a card that we received through the system, and the system followed these steps. So Android gives us an API for, well, for different technologies. NFCCA will be equivalent to ISO 11443A, FCA for the same ISO section B, or other cards. Well, differences, Felica cards, more used in Japan. They have their own protocol. And then there is another protocol for vicinity cards, not proximity cards. All these technologies are based on the transif method. So we have bytes network, and then from my application, these transifs, I invoke the NFC service of the system. That's why we need to ask for permissions for NFC when we install the application. And then the service system will generate an NCI message for the controller, and then the controller knows the protocol we are talking about, and because of that, it will take our payload, our bytes array, and it will insert the headers or whatever it needs, and then it will send it out to the Wi-Fi network. And this is the host card emulation. So in this case, we can ask our mobile to listen right away. So the application should extend to the host APDU service, which is an abstract class. And basically it says, implement the process command method, and you will get the same response. So whenever we get a message from NCI, because it is in the reading mode, it will invoke this method based on the bytes root. We will work with it as we want to work with it. Then we do a return with that byte network, and then the process will be the same. We send it to the system through the NFC to the controller, and the controller will send it to the remote track through Wi-Fi. So what is the problem here? Well, Android forces us to restart the communication with an explicit information because it has some routing tables for IDs. I guess that you have different applications to emulate tags. So one has to respond to the paid tags, the other one tag to walking or go to your gym, and then it will keep those tables. In these tables, it keeps the ID of the application or the service or the application that will emulate it. When we get a select command, we will take a look at the service that we will listen to, and then this method is invoked. And well, this is the summary of the layers that we will have in our stack in NFC Android. So down below it says unknown language. That RM is a Cortex chip. I think that's the name of it. Well, but we will have to do reverse engineering, okay? So implementation is open source. We have that in the Android open source project. As you can see in the last column, it tells us which is open source and which is not. The last one is not open source. Oh, I had that slide before. Well, okay, shouldn't be there. And now, a demo, so that you can see what we can do with Android. Okay, 3 protocols: communication protocol, communication about the format of the messages that you sent out, and now we will see a practical relay attack. I will be communicating with a card through my mobile phone, and then you will see how we make one transaction from one point to another. So the security principle that NFC bases itself on which is a principle of proximity, we will break it, okay? That's what relay attacks are based on. We break the proximity principle. There are articles talking about a maximum distance for you to do the relay attack. Well, some articles even mentioned like 15 meters, depending on the type of hardware. In terms of relay of communication in the channel, just in case you are thinking about that, defines a maximum of 5 seconds. That's the standard, maximum of 5 seconds. You can have point-to-point communication, maximum 5 seconds. So I created a related channel through Wi-Fi for my transmission. I will be using this mobile Nexus 4, which acts like a proxy with host card emulation. So, well, so that you can see that we can do that at a distance higher than 10 centimeters. So I bring the card close to my phone. So, well, we have a video, okay, just in case we need it. Okay, this one is not detected. Do you want my card? Can I borrow an NFC card from any of you? Okay, credit card. Okay, that one, that one.
Ese móvil. Es que es el móvil de mi madre. Me lo mandó ayer por correo. No es broma, no es broma. So messy things in between. Let's check it now. Oh, the cats are not moving on screen. It's my mobile phone who is interfering. Shut down the NFC and reactivate it. Shut down the application. 1 minute please. We're going to reinitiate Android system. The god of demos has been invoked. It's a good thing that nobody knows this book from Windows MPC with a specific security stuff, because you may be smashing and cracking our demo. Last attempt, last try. Igual tienes que volver a... Pero es curioso porque... It's a funny thing. It never has had the very same mistake. Channel established. Is the reader of our mobile, which may be screwed up. You can change the mobile. Please, I should try your mobile phone. I'm sorry, good man. No way, Jose. Sergio, please, can I borrow your mobile phone, please? Okay, in the meantime, I can tell you a tale. People are leaving the room. Why? Please, can you explain the video to our guys? Well, I will tell you about this video on screen, and I'll get a call in. In the meantime, did you get it? How on earth did you get this? Do you have it installed on your smartphone? Okay, anyway, I will explain it on this video you are gonna see. Oops. Oh, it's a messy thing. This video was made and shot for studying at for the last course of our degree. A mole on the left, proxy on the right. There is a channel of communication being established in between. a communication channel is established, there are some blur images due to protect private data. It's not good for us to publish personal data on. And now the communication has been established between point of selling terminal with the one you can get in the ticket out and sale perform, always with sales of 10 cents of euros. So the TPU PP is using was inserted in a blacklist. The good thing is nobody has charged the testing 10 cents because they thought it was a testing thing. They were experiment. Adrian, you're over here. This is Adrian's card. Thank you for your card, guys. Does it work? Does it work with the other mobile phone? It doesn't work. Oh, what the fuck of it? The other mobile phone does not have it installed. Ellie, all this is testing on the go. I seem like a movie star being awarded a prize. People, all our fellow members want to go to have their lunch.
Vamos a ver si sale al menos para que veáis.
So let's see if you can see the triplet. The triplet, please don't leave the room, but they can feed us inside the room. I'll create a relay. The channel is well established. Roman told me there are special pastry for all of you who are waiting for the end of the show. In the meantime, I will step up and move forward. I will tell you about these, what POC attack scenarios are possible with this kind of a story we are telling you. Something like this on screen. Let's imagine we infect a series of mobile phones such as L, which has the application installed, and he's listening, and trying to see if there is any card in proximity, and whenever you get a card in proximity, an SMS comes to me and says me, okay, I do some sales with a TCP, and they are going to ask you for your identification when you are going to buy a TPU. The objective of these contact payments needs to save money, save time, especially to save time. You're going to, for instance, to the cinema Cinesa. You're going to cinema, to the theater. You can touch the tactile screen. You can pay with your mobile phone any kind of tickets. Nobody verifies your identity when you pay the ticket with your mobile phone, but the market on the market is a special thing. Don't say that. Let's imagine you can do a fraud with a TPU, which is very good. But let's imagine I have Russian friends, Ukrainian friends, or Easterners who come over here and have some TPUs installed. I know who they are. I comes up to them. Okay, please, give me your card, and we are all together, half. And is the distributed mafia fraud, not only having one single networks infected, tackling all the cards. We have also a TPU which is also malicious and malign, acting all together with the rest of the things. You're gonna tell us, my goodness, my gosh, if you do one single payment, you're gonna be caught. They're gonna catch you. You're gonna be caught. I have so many friends, so we create a network of friends to commit crimes. This would be a possible scenario, but banking systems are implementing security mechanisms in order for them to detect short-time fraudulent transactions. So in that very moment, they cut all the transactions on the go radically. So I will tell you about the limitations and the conclusions. Okie dokie, all this is feasible on Android non-modified devices with the without customized software and without permissions of root. This can work with credit card because they are easily they meet the four standard specification, but this is not going to work with Mayfair Classic cards because it does not support commands at protocol 46 because is raw, is gross. Now the channel is established, the model is connected with the card. I can initiate the payment with the TPU. I take my mobile phone. I insert 1 cent. Otherwise, they will charge me a commission. And theoretically speaking, if I accept right now, the payment will be made. There's a relay, and I have all the tracking down kept and connected with the server, receiving a response. This is the MBA protocol tracking down, negotiating. And I have a stack of bytes. Is out of coverage over here. We're waiting for response. Is there any coverage here? This is going through 3G. Oh, we got it. We got it. We made it.
No está soltero.
My friend is not single. He's not a bachelor. Nor am I. We can make an exception. I want to tell you a transaction. You will be asking yourselves what kind of information is being conveyed, transmitted. These flagshot bytes. What are these flags like? These bytes are what José Esparza told us 2 years ago in another event. Basically, the information transmitted on any FEC communication is the number of the car, which is in the frontal part, the date of the expiry date, and the holder of this car. The CUB is in Stephen Sound. For instance, on Amazon, with this type of information, you will be able to buy things. With FEC attacks with tip lists were not made. They capture. I wouldn't go deeper and deeper, but other kind of attacks in the lunchtime we'll talk about. Another funny thing is when you have a ticket printed out, there is a par with a number starting by A0000, which is the application. If it's the ID of the application, like a mustard card, you can go on with the support. Like as we say, the emulation is restricted by the Rapid of Android, the block with the headers of CBRs, and all the transmission messages cannot be emulated. The final word, the chip, is capable of emulating those nodes, but the system will do so. So, in the future, we can do support to the Android operating system to do lower level relays. If some student here is interested, please tell me about. Like I said, ID rooted tables demands explicit selection, and we need to know beforehand the ID of the application we are going to emulate. You can do so with root. You can skip it with root because there will be an application receiving all the SLX. Regarding the time, this is a formula for the maximum windows at 5 seconds, defining the standard by on Android is fewer seconds. FW would be an 8, and it would be like 87 milliseconds. If we had a low latency channel, we can do a relay to a longer, a wider distance. Countermeasures. Oh, this is a fucking thing. My goodness, bullshit. What can we do to avoid this kind of attacks? We are now investigating, researching on other kind of protocols, such as protocols trying to find out and limit the distance between the devices being communicated to try to detect the relay in the communication. If there is a longer delay, it means there is a transmission and it's cut down automatically. Regarding the hardware, identification of radio frequency devices, physical activations. There are some cars will tell you, okay, this car besides set NBC requires to press a button and to have a slide or a tag or a switch. This is it. Or we can use another kind of security additional mechanisms. Not only with NFC, it also requires to have your digital fingerprint on a reader of digital fingerprints. These cards are known as SWIP. We are now being implemented. Our conclusions, we can do it without Android. In the very end, allows us, before you needed a specialized hardware to intercept communication. You want to know how a reader in a car works. Now with normal Android devices, if you are lucky to have a standard devices, you can capture these list of devices and PPUs, and from then on you can see the information which is exchanged. All these advantages given by Android can be abused by malicious software. So now we let you go and have your lunch. Thank you.
Es que hago vinagre.
I'm creating balsamic vinegar. Somebody can tell me afterwards. Any questions, please? See, you all guys have lunch every single day, so you can ask me some questions. And I have also balsamic vinegar for all of you, prepared by myself. So later I can give you sandwiches and delicious things. Ricardo, over here, Ricardo. I'm over here. Beforehand, my congratulations for your project and talk. Basic question. According to what you have explained to us, a possible risk scenarios. I get on the bus. A guy comes up to me. He can register my car, and when I walk by a big storehouse, he can do a sale. He can only need a Wi-Fi. We are talking about communications on 3G, 4G. Is this a possible feasible scenario? Yes, it is. It's feasible. We had a virtual pickpocket. As José said, you can come up to an onion, but they charged me. And we're talking about the Android device has a distance. It's not you need to come out very close to the Android device. So come out very, very closely to the Android. They charge me, they steal me. You can use USB antennas to the mobile phone on Android, and it's visible. They can steal you all this information from you. We will come in together at 3:45. At 3:45, everybody should be here again. 3:45 p.m. Everybody back. What about the staker? Okay. I pick my mobile phone. I come closer with my car. I'm touching the TPU. But this is. Have you ever thought about attacking the API of TPU to make automatized payments worth of 20 years? This can be escalated. You can escalate the whole thing. Everything is possible in this life, but let's bear in mind the time limitations. We invested and spent 500 hours for this project. It's true that in the first case, in my understanding, we are talking about deep play attacks, not feasible, because there is a cryptogram in between which activates with every single payment, and you may need to repeat the same request 20 times. Or you can come up to the weak boy on the bus and do so. There is malware for TPUs. In the very end, is another line of investigation. Please don't panic. Don't panic because the NTC cards over 5 transactions made with contact lens, they access for a PIN, so they can steal 100 euros from us. It's not too much, by the way. This is going through protocol TPU. On NTP, the relay is inherent to the protocol NFC. More things, please. More questions. So we'll be reachable on the lunch. time. Thank you for coming.